but we were told to draw only the forces acting on track A. So they say all the forces, which means even though the track is moving horizontal, we will still include the vertical forces. Now, for a free body diagram, we indicate a track with a dot, and also we were told the length of the vectors should be an indication of their relative magnitude, which means if we have more magnitude for the other force, the other one, the opposite one must have a shorter length. Let's start with the one that we normally draw. FG and F normal. Then your lines must have an arrow, and also you will get 1 mark for just writing, for drawing this arrow showing the direction of FG and also indicating the type of the force. So this is the direction of motion. So if the object is moving in that direction, it means that there is an applied force, because it says here, the engine of track A produces a force of 11,270 newtons. Now we have applied force. I normally say to the learners, just write applied force as it is, because some of the abbreviations that we use, you'll find that they are not acceptable during the exam. So because the track A is moving to the right, then we have the tension that is pulling in that direction, F tension. And also we have F friction. But not forgetting that our lines must not be the same. And then these two lines must be parallel to one another, and all your forces must be attached to the dot. Then you will get 1 mark, 1 mark, 1 mark, 1 mark, 1 mark. And also the other mark is for you not having the same length of the forces. Then you will get that 6 marks for just identifying the forces acting on the object. Then the next question says, calculate the coefficient of kinetic friction for tire rubber on the road surface. Calculate the coefficient of kinetic friction. Now, when we calculate the coefficient of kinetic friction, you will say, it's number 2.1.3. Kinetic friction is equal to the coefficient times the normal force. So the normal force, the coefficient for kinetic, we were given the friction force of 8,820. Then our kinetic, that is what coefficient, that is what we are required to calculate. And we know that the normal force is equal to mg. Remember, it is in opposite direction to the normal force. They are the same. These two forces are equal, but they differ in direction. So the mg mass of track A, or what were you we are required to calculate the coefficient of the kinetic friction of a tire rubber on the surface. So we are going to use track A, 4,500 times 9,8, and then we were given the friction. So the friction is 8,820. Then we do our mathematics, whereby we are going to multiply this and divide it by that. So the answer will be 0,2. So there is no unit for a coefficient of kinetic friction. So this one was straightforward, was easy. That's how we calculate the coefficient. Now the next question says, calculate the force of friction exerted by the road surface on buggy B. Calculate the force of friction. So for you to be able to calculate the force of friction, you must be able to go back to what is it that you were given. Let me use the clean page. What is it that am I given, so that I can be able to calculate the friction force exerted by the road on buggy B. Now, in this case, on buggy B, let's identify the forces acting on buggy B. We have tension, force in that direction, and we also have kinetic friction. Why am I not saying friction? It is because we do not have the magnitude of friction, but because the object is in motion, it means that the friction is there, but now we will be able to calculate it because it was not given. Now, the first thing that we must do, we must first calculate the kinetic friction. But how do we calculate this? We cannot calculate this if we do not use this equation. F kinetic is equals to the coefficient of the normal force. But we must also have the magnitude of the normal force. So let's calculate the magnitude of the normal force. We all know that the normal force is equals to Fg is equals to mg. Then our mass is 1,250 times 9.8. Therefore, the answer will be 12,250 newtons. That is the normal force. You can calculate it here, or you can just calculate it separately and then take the answer and substitute it here. Now, we calculated previously on the previous question, we calculated the coefficient of kinetic energy. So the coefficient of kinetic energy, already it is 0,2. Remember, the string is 1. So we will use that coefficient is 0,2 multiplied by 12,250 newtons. And then the answer will be 2,450 newtons. That is the magnitude of friction. Then when we move on to the next question, it says calculate the tension in the rope. So when we calculate the tension in the rope, let me just write here. The first thing that you do, just say F net is equals to MA. And when we look at our equation, we only have one of our diagram. We only have one rope. So you can either use one of these forces that you have identified. Then you can either use the simultaneous equations to calculate that. But not forgetting that we were told from the beginning that the track travels at a constant velocity. So this means that we do not have an acceleration. If the velocity is a constant, we do not have acceleration, because we know that acceleration, it is the rate of change of velocity. So it means that the initial velocity is the same as the final velocity, and when they subtract each other, they will give us 0. So the acceleration is 0. So let's take track A. Let's use track A to calculate the tension. For MA, we have 4,500, which is the mass, times 0. Where is this 0 coming from? This 0 comes from this constant velocity. So if the velocity is constant, the acceleration will be 0. Now, for F net, because we identified the forces acting on an object, and these vertical forces are not doing the work, so I cannot use these forces for my F net. But these three forces will help me to get what I'm required to calculate. Remember, the F net, it is the sum of all forces acting on an object. So what I'm going to do, I have F applied plus F done by the tension plus F done by the friction. So I put them as positive because F net is the sum of all forces acting on an object. Now I am going to substitute. When I substitute, I know that I always say, because this was the direction of motion, it will always be positive. I always choose the direction of motion as positive. So my applied force is 11,000. Here it is. I was given the applied force. Here is the magnitude. It is 11,270 plus. Now, the tension and the friction force are in opposite direction. So, which means if my applied force is positive, these ones will be negative. So, I am going to substitute my tension as Ft plus this one, friction, it is also in the same direction as the tension. It will be minus, we just calculated it, which is 2,450 newtons is equals to 0. Now I'll make Ft the subject of the formula. So my Ft will be equals to 2,450 newtons. That's how we calculate our tension. You can still use the Baki. You can still use the Baki to calculate that. You can say F net, remember the tension will be the same for both Baki and the track. F net is equals to MA. So here we used the track A. Here we are using the Baki. Your answer must still be the same. But with constant velocity, we are going to multiply, we are going to substitute our acceleration as 0, and then our F net, we have T up in this direction. Here is T in opposite direction of motion, so which is positive minus. This one will be, it was calculated, which is 2,4. Then if this gives us 0, T will be 2,450. T will be equals to 2,450 newtons. It doesn't matter which object you use, your answer will still be the same.